Section 8.2. This section we're going to talk about solving exponential equations and inequalities. What we mean by an exponential equation or an inequality essentially is these are the types of equations where the variable is in a power. So instead of talking now about, things like 2x equals y, or equations like 2x equals 8, I should say, we're going to be looking more like equations of 2 to the x power equals 8, and we're going to try to solve for the variable that's missing in the power, okay? And there are some ways to do that. The way to do that for most equations is going to be this property of what we call exponential equality. And what that essentially means is if you have a base that's positive, okay, that's not equal to 1, then that means if you have like bases equal to each other in an equation, b to the x equals b to the y, that's only going to work if the exponents are the same, which makes perfect sense, right? I mean, that's the only way you're going to have two numbers to be the same. If b's are numbers and the variables have to be the same in order for the exponents themselves to be the same. Okay, that's what's going to let us solve equations that have variable exponents. Essentially, what we're going to do is we're going to get like bases on both sides of an equation and then just focus on the powers themselves. So let's look at some examples of that. So the first one we have is 2 to the x equals 8 cubed. So see what I mean now? The variable x we're trying to solve for is in a power. It is not a coefficient. It is not a constant. It is a power of 2. So the first thing we want to do is we want to see do we have like bases on both sides of this equation. And we don't because we have a 2 and an 8. But 8, we know, is the same thing as 2 cubed. So why don't I rewrite 8 that way? So my new equation is 2 to the x equals 2 cubed to the third power. This 3 stays in because the 2 cubed is just another way to rewrite the number 8. Now look what happened here. I have properties of exponents at work. I have 2 cubed cubed. So I'll take these 3's and I will multiply them together because when we have a power to a power, we can do that. Now I get 2 to the x equals 2 to the 9th. And now we get to go back to that property from the last slide. I have like bases. So all I must do is set the two exponents equal. Now I can rewrite this problem as the equation x equals 9. And what do you know? I've solved for x. X is already isolated. X equals 9. And if you were to check this, 2 to the 9th power does get you the same thing as 8 cubed. All right, let's look at the next one. 4 to the 2n minus 1 equals 64. Now, again, I don't have like bases yet, but this is rigged. 64 is the same thing as 4 cubed. So why don't I rewrite 64 like that? And hey, I can now set 2n minus 1 equal to 3 because both sides of my equations are using base 4. And I can solve for n the same way we've been solving equations for a long time now. N equals 2. Okay? And you're going to notice in this chapter, as well as a lot of the other chapters we do the rest of the way through the course, I'm not going to teach you any new algebra. The new part is getting the problem written in such a way that we can use the property to turn this into an old, easy-to-solve algebra problem. It's going to happen a lot in this chapter. Okay? You have a couple examples to try on your own. Go ahead and pause the video and do that. When you're ready to pick up on the next concept, you can pick up the video here. Okay, so now let's talk about how to find an exponential model. What I mean by that is I'm going to give you 2 points, and you're going to use the equation of an exponential function, which we saw before is of the form y equals a times b to the x, where a and b are parameters. They're going to change in the problem. That's an exponential model in its general form. Okay, this is the general form. Again, you saw this in section 1 of this chapter. So the first problem we have is we want to write an exponential function for the graph that passes through the point 0, 6.4 and 3, 100. I'm just labeling my points, the x and y coordinates, so we don't forget. All right, let's start with the first point, 0, 6.4. And let's plug in what we know. So we don't know a and b, but we do know that y is 6.4 and x is 0. Now, this is nifty. B to the 0 is 1 because anything to the 0 power is 1 from Chapter 6's properties of exponents. So that must mean 6.4 has to equal a times 1. In other words, 6.4 is a. So I got one of my two parameters that's going to help me figure out this function. To get my second parameter, I'm going to use my second point. So the function, now I know y equals 6.4 times b to the x. Y is 100, a is still 6.4, and x is 3. And b again now is the only variable that's missing. So let's solve for it. Let's divide by 6.4. Okay? So that means b cubed is going to equal 100 divided by 6.4, which, if you get out your calculator, which is what I'm about to do, 100 divided by 6.4 is 15.625. Okay? So that's b cubed. I want to get b. So how do I get b? I'll cube root both sides. And the cube root of 15.625 is 2.5. So b equals 2.5. So I now have my parameters a and b. So I can say that the function that passes through those two given points looks like this. Y equals 6.4 times 2.5 to the x. Okay, let's try another one. It's a little tricky, but with some practice you'll get the hang of it. Okay, now this time I have the point 0, 128 and 5, 371,293. By the way, I always have to have this initial value. I have to know what y is when x is 0. Otherwise, I can't really do this yet. Okay, and the reason being is this point will always allow me to get a. In fact, you can generalize this and take a shortcut. A has to be the y coordinate when x is 0, because again, you've got 128 equals a times b to the 0. That part just becomes a 1, so 128 equals a. This is very important because eventually, later on in this section, we're going to do these same sorts of problems, but they're going to be embedded in a word problem. Okay, I'm not going to give you the points explicitly like this. They're going to be hidden within a word problem. So it's good to get an idea of how to write functions of exponentials using a pair of points. So I know in this problem that a is 128. Now I've got to use the second point to figure out b. So now we've got, so far we know a is 128. We don't know b. So we'll plug in what we know. 371,293 is y, and 5 is x. All right, so I'll divide through by 128. Now I get b to the 5th is going to equal 2,900.726, and I cut it off there but it keeps going. So why don't I take the 5th root of both sides? And that means that b is approximately equal to, because again I have a nasty decimal, 4.926, and then there's a 0 and it keeps going, so we'll cut it off at the third decimal place. So there's my b, there's my a, so that means the exponential model that I want is y equals 128 times 4.926 to the x power. Okay, you've got a couple examples of these to try in your notes. Pause the video. You can rewatch this if you need to. I know this is a little bit trickier than the first thing we did in the video, but give it a try. Okay, the final thing in this section is inequalities. They're just like equations. The only difference is we're going to have inequalities once we set our bases or set our exponents equal to each other. Now we're going to set one greater than the other or less than the other. So let's look at the first example. 3 to the 2x minus 1 equals 1 over 243. Okay, so I've got to have my base be a number that is greater than 0 and not equal to 1. Okay, so 243, that's 3 to the negative 5th. So all I do is I rewrite this problem as 3 to the 2x minus 1 is greater than or equal to 3 to the negative 5th. And again, the 3's become irrelevant. Now all I do is I write the inequality 2x minus 1 is greater than or equal to negative 5, and I solve for x. 2x is greater than or equal to negative 4, so x is greater than or equal to negative 2. Okay, let's try the second one. All right, so I'm probably going to keep the 5 the same, but 625, that's 5 to the negative 4th. Excuse me, 1 over 625 is 5 to the negative 4th. So we get 5 to the 3 minus 2x power is greater than or equal to 5 to the negative 4th. And then again, we just focus on the exponents. 3 minus 2x is greater than or equal to negative 4. Subtract 3 from both sides. Now look here. The rules of exponents, the rules of inequalities will continue to be followed from the beginning of the school year. I'm dividing both sides by -2, so that greater than symbol becomes a less than. Okay, and in fact, there should be no equals here. These were strictly greater than, so let me erase that. So x is less than positive 7 over 2, or positive 3.5 if you like decimals. Okay, you have a couple more that I want you to try on your own. We're going to do a little bit more practice with this in subsequent sessions in class, as well as start looking at some word problems that involve exponential equations and inequalities. Okay, with that, be sure to ask me any questions about this video. Thank you for watching, and I'll see you in class.